Okay, hi. In this video, we're going to go over the solutions to the Algebraic Problems 1. So we have a race car accelerates from rest to 287 kilometers per hour in 6.8 seconds. What is its average acceleration? So the first thing that you want to do is make a list of everything you know. So it says it goes from rest, so that tells us that v naught is equal to 0. It says the final velocity to a speed of 287 kilometers per hour. Let's note that that's going to be a problem because we're going to want it in meters per second. So we're going to come back and fix that. We know that the time is 6.8 seconds, and we are looking for the acceleration. So there we go. First step is always to make a list of everything we know. Like I said, we're going to need to come fix this 287. So let's fix the 287. 287 kilometers in 1 hour. Let's see here. So we're going to want to change that to meters per second. So 1 kilometer is equal to 1,000 meters. Kilometers are gone. 1 hour is equal to 60 minutes. Hours are gone. And 1 minute is equal to 60 seconds. On the top, we have 287,000. And on the bottom, we have 3,600. Divide those. And you get 79.7 meters per second. So now if we look at the information that we have a velocity, we have time. The only one that's going to have that is the Paul equation. So that's that one. Write it out blank like so. Now plug in the information that you're given. So 79.7 equals 0 plus a times 6.8. We're going to divide by 6.8. 79.7 divided by 6.8 is 11.7. All right. Next up, the space shuttle starting from rest. Okay, so starting from rest tells us that the initial velocity is 0. Undergoes an acceleration of 53.9, so a is equal to 53.9 meters per second squared. How far? So that means we're going to be looking for x or delta x. And we have that t is equal to 55.2 seconds. So looking at the information we have here, this is going to be the John equation because we're looking for a relationship between time and distance, and that's the second one, the John equation. So write that out. We can set x not equal to 0. The reason we can do that is, let's see here, we have a space shuttle. So if you kind of imagine the space shuttle, we'll say it starts here, and we would like to know, how far it's gone upwards in that amount of time. So we'll just say that the ground is 0 and that it's whatever its position is at the top is what we're solving for. So that means we're looking for x, put a 0 in for x naught, 0 in for the initial velocity. These two terms kind of go away, so we just have the n term. So 0.5 times by 53.9 times by 55.2 squared. Make sure only the 55.2 squared is squared. And you get the x position is 82,117, 118. It's 0.7, but okay. Okay, there's that. Moving along, you're in an elevator that is accelerating upward at this rate. The meters per second squared tell you that that's the acceleration. How fast, so that means we're looking for the final velocity, are you going after traveling 13 meters? So that tells us delta x is equal to 13.3 meters. Which could also mean, right, alternatively, this could mean that x naught is 0 and x is equal to 13 meters. That would be also the same. So if we look at this, what we're not given is time, right? There's no time in this problem whatsoever. And so what that means is that's going to be the last equation, the equation. And that's going to be, we're looking for the final velocity. We can assume the elevator starts from rest because it's hard to get on elevators when they're not moving. Even though it doesn't say what the initial velocity is, right? Generally, elevators would start from a velocity of 0. That's how you get on them. And obviously 0 squared is 0. So plus 0 is doesn't matter. Square root both sides. Square root of 121 is 11. Okay. Moving along. A car traveling in a straight line has a velocity of 5 meters per at some instant. After 4 seconds, its velocity is 8 meters per second. So if we write all the things down that we know, an initial velocity is 5 meters per second. Time is 4 seconds. Final velocity is 8 meters per second. And we would like A, right? So that's what we want for this one. So as we look at all of this information, right, we have velocities, we have times. So that's going to be the Hall equation, the first one. Again, just match, the variables that you have to the variables that are in the equation. So we don't, right? Hall is the one that has those 4 variables, right? John would have an x in it, so we don't have an x and we're not looking for an x. Ringo doesn't have time, so then we plug in the information we're given. So we got our 8, we got our 5, our 4. Subtract the 5, that's going to give us 3 is equal to 4a. A is equal to 0.75 meters per second squared. Right, divide the 4, that's going to give you 3/4. 3 divided by 4 is 0.75. So next up, how far did it go? So now we would like to know x or delta x. And so there's a couple ways to solve it. You could solve it using either the Ringo equation or the John equation. I'm going to use the John equation, but because you kind of know quite a bit of information, either one would have worked. So let's see here. We'll say it starts from 0. In this case, we do have to use this term. We would put a 5 in there. Time is 4 seconds plus 1/2 times by And acceleration, we just figured that out, 0.75, 4. Obviously, the 0 goes away. 5 times by 4 is 20 plus 0.5 times by 0.75 times by 4 squared, 6. So x goes 26 meters. All right. You did not have to do number 6. So first up, we have a car that's traveling at that speed. Let's just go ahead and switch. We know we got to switch that into 108 into meters per second, kilometers, 1 hour. 1 kilometer is equal to 1,000 meters. 1 hour. Oops, nope, that's not where it goes. It goes on the top so that it cancels. 1 hour is equal to 60 minutes, and 1 minute is equal to 60 seconds. That way the hours cancel, kilometers cancels with that, giving us meters on the top and seconds on the bottom. So that's going to be 108,000 divided by 3,600. 108,000 divided by 3,600 is going to be 30. And we got to do it for 135 as well. Thousand meters, 1 hour, 60 minutes, 1 minute, 60 seconds. So that's going to give us 135,000 divided by 3,600, and that's going to give you a velocity of 37.5. This is your initial velocity because it's the velocity you start at. This is your final velocity because it's the velocity you end at, right? Because the car is traveling 108. So we have our initial velocity is equal to 30 meters per second. Our final velocity is equal to 7.5 meters per second. Our time is equal to 3.5 seconds. Okay, so right, because they're going this speed, the road's finally clear, the driver stomps on the pedal and accelerates up to that speed, 37.5 meters per second. Takes 3.5 seconds to do this. What is his average speed? What is his average acceleration? So what's A? For that, it's going to be the Paul equation again because of all the stuff that you know, right? No x's, no distances, anything like that. Plug in the stuff you know. Subtract, you're going to get 7.5, right? Because you subtract the 30 over. Divide by 3.5. So 7.5 divided by 3.5. 2 point. And there you go. There are all your answers for Algebraic Problems 1. I hope this helps. Thank you for watching.